So, as Bruce pointed out, we've got our data now from 2 trips, and we're doing one more 3 months from now. But I think what's most notable about this is just to show you guys what kind of a year we're having here. You know, in addition to, you know, some things being higher, the temperature is the one thing that across the board is quite a bit higher. It's in some cases twice as high as it was when we were there back in November. So that's concerning because normally in February we should have been shivering the most. It should have been one of the coldest times of the year, right? However, we've had an unseasonably warm winter. That's why this year alone, spring is about a month ahead. So normally you'd have about a month left to put some of these plants into the ground, but because it's a month ahead, things are already starting to leaf out. So we've got to get them in as soon as possible. So we're going to be traveling down to the bioswale after we talk a little bit more about this to do some planting of Spirea glassii and Carex leguidii, which are both species that do a lot for water quality because I know some of you know why. What do these deep long roots do to the water quality of our area? And particularly the bioswale where there's a lot of runoff in the parking lot.
They suck out all the nutrients.
They suck out the nutrients, they suck out a lot of the oil and pollution that's run off from the very parking lot that we pull into every day. So it's an active filter. It's kind of in a way I like to think about it like a sponge. Not only does it hold the water, as we will find when we go down there, but it also holds in a lot of that nasty stuff that otherwise would end up washing down either to our drinking supply or back into the ocean. So, you know, this is really, you know, I kind of wanted to show you guys, this is a small data set so you get a little better picture on how each one of these sites is so different. You know, at Crowley Creek, even though the temperature is higher and we're seeing more dissolved oxygen, we need to think about the habitat that's there too, and the fact that above Crowley Creek is a very steep system with a lot of intact forests that surround it. So, what do we think is going to happen when it heats up? Do we think it's going to be susceptible towards things like dissolved oxygen dropping way down, like we see, you know, over here Drift Creek? Even though Drift Creek is a very intact watershed, when the temperature goes up, we did see a drop in dissolved oxygen there. So that lets us know that Drift Creek maybe doesn't have as much intact habitat above. So some of these things like dissolved oxygen are having more time to heat up or less time. It's not as steep of a system either, so there might not be as much oxygen just getting put into the water. As the water drops, it turns over, and that is why we have higher levels of dissolved oxygen at Crowley Creek, I believe. But that's just a hypothesis. So, you know, this is an important data that we're collecting because it tells us a little better picture about what's going on there. And just because we think temperature decreases, dissolved oxygen increases, in nature it might not always be that. So we need to collect more data to understand exactly what's going on and maybe why Crowley Creek is better suited to deal with those changes in seasons like we're seeing right now, where we've, you know, after our field trip, we went to, you know, the water treatment facility as well and looked at that, how we actually filter our drinking water out of Schooner Creek. And, you know, I went and collected at Drift Creek, and Drift Creek normally in February is supposed to be at about 8 feet. Well, it was about 3.5 when I was up there last. So the water flow is about half of what it normally is this time of year. So just think about that now, because I guarantee when we get into the summer, there's going to be some conversations about how much water is left for our watershed and our drinking water, and ultimately, come next fall, our salmon. So, you know, these are all important indicators about what is going on. And on a real quick, I just want to pull up the Null Earth. Just go to Google. What I want to show you guys is this is a small data set. I think it's this one. This is a small data set.
That's not it.
No, it's this one in the middle, yeah. So this is a small data set, but this is big data. So, you know, taking the work that we're doing to collect a small amount of data is painting a very detailed picture about our watershed. But when we look at the world watershed, we can get also another sense about what's actually going on and why have we had such a dry winter and that's been so relatively mild. Well, this is one of the reasons. If you see, actually, why don't we pull it down? You can see the temperature up in Alaska here is almost the same as the temperature. It's, it's a bit cooler once you get up here into the Kodiak and whatnot. But in here, where normally we would see water that was this dark blue, we're seeing temperatures that are comparable to what we have in Oregon. And in Oregon, the sea temperature is up about, 3 degrees anyway. So, but those might seem like minor changes, but because water has a very high heat, which is a word I feel like you guys you've learned this before. Water has a high heat capacity. So it can hold a lot of heat, it can also hold a lot of cold. But depending on which side it gets on, it will hold that. It has the capacity to insulate. That's why, people use water to insulate their tomato plants, because it keeps, the tomato warm. But it also can keep our oceans too warm. So when we had up here, where we've had, much warmer temperatures, there hasn't been as much snow being created out of the Gulf of Alaska that would normally, our weather comes down and hits us kind of like this. Well, this year it's been coming up from here because we're in what's called an El Nino. How many of you have heard that term before? Yeah? So the Peruvians were actually the ones who coined it, because the Peruvians, they're the ones actually most affected by this. Why don't you take us to the Galapagos?
I'm not sure I know how to do that.
You just gotta grab the...
Oh.
So yeah, so you guys, anytime you want to get you want to try and figure out what is happening in our world and why is coral bleaching happening over here on the Phoenix Islands, or why is, the Galapagos Islands are right here. This is the equator. Normally the Galapagos has water temperatures that are actually pretty cold because of this current is normally much colder coming up here from Antarctica and directing cool water into the equator, which is why the Galapagos is such a diverse place, is because it's this mixing area of cold, warm water, lots of nutrients, and ultimately it's on this big, equatorial current. So a lot of nutrients are brought through there. So, but this year, normally we don't see temperatures quite like this, but it's shifted. Normally the temperatures are warmer, just kind of in here, but this year it's shifted going even further north. So that's pushed a lot of the ocean temperatures much warmer over here. Now, over in Boston and the other side of the country, where they've been getting feet of snow, and Alaska has been getting no snow, I'm a big skier, and over spring break, I was in Utah visiting some friends, and they were getting more snow than they were in Alaska because of the way in which the weather had changed. Ultimately, over here, look at how cold the ocean is still. And even though we're all the way up here, there's more cold water down here, and that's where this polar vortex has been sucking. Water likes to go from hot to cold. So if there's a hot area, like up here, it's going to try and move to equilibrium and move across the North America to get over here where there's more cool ocean temperatures. So that's why a lot of the weather's been going like this, as well as the warm weather has been coming up here to try and displace itself across, parts of the south. Colorado and New Mexico have actually been having a pretty good winter. So,
You ever heard of the Gulf Stream? This shows it pretty good. It's
Yeah.
the red tongue coming right up here. Sometimes travels at 17 knots. It moves pretty fast and goes right up the east coast, coming out of the Gulf. A warm current coming out of the Gulf of Mexico goes all the way across, even warms
UK.
England, UK over here.
And look at how far north the UK is. The UK would almost be up here in northern BC. So, which is a much cooler place than Great Britain is, which ultimately, if the whole reason Great Britain is more like our climate, even though it's so much further north, is because of this ocean current. So I just want to show you guys earth.noelschool.net, just because this is the way I kind of make sense of what's going on and try and look at, okay, when's it going to be a good time to go skiing? When's it going to be a good time to go surfing? When is it going to be a good time to go on our next field trip? So this is, a really amazing tool to visualize the data.